eBPF internals. Everyone knows eBPF code is a program which runs inside kernel. And in this video, I will explain how that happens. In Linux system, we can distinguish the application running context into two, user space and kernel space. User space is where we write, compile and execute the Go program for eBPF application. Go program acts as a loader or controller for eBPF code which is actually executed in kernel space. So essentially, green box you see here is your application development environment. Here we write the eBPF instructions in C and compile them using clang to the BPF bytecode. This C program will contain program and maps. Program is just a set of instruction and map is nothing but key value pairs. So this map is used to interchange data between user space and kernel space. This is all about what happens in user space just before the eBPF code is loaded into the kernel. Now here, the Go library, as I mentioned before, acts as an interface and send the BPF bytecode to the verifier. Verifier makes sure that the code is safe to run in the kernel by checking some rules. For example, the program cannot have any infinite loop. If any such checks fails, then the program will not be loaded to the kernel to run. After the verification, the BPF bytecode gets compiled by JIT compiler, just-in-time compiler, and this translates the generic bytecode of the program into the mission-specific instruction set. This will optimize execution speed of the program. That makes eBPF program run as efficiently as natively compiled kernel code or as code loaded as a kernel module. After compilation, it gets attached to a hook and get executed whenever that function call happens. Here in this case, it can be a TCP retransmission request. And this is it. Here I explained this with Golang, as in this course we will be mostly using Golang Selim eBPF package. There are other programming languages like Python can also be used in similar way.